Derivations you may need presence. Electric field intensity at the center of a charged arc. Suppose we are said to find out the electric field intensity due to a semicircular arc, which is part of a circle of radius r. At the center, let's say this point P. The arc is symmetrical in nature. We draw coordinate axes and place the arc symmetrically across the axes. The arcs subtend 180 degrees at the center. On one half, let us assume a very small part of the ring dx. Let this small arc subtend d theta angle at the center. Let vector of electric field intensity due to this dx part be dE vector. Let this vector make phi angle with horizontal. This angle will also be phi. Breaking the vector into its components. Since the arc is symmetrical, we also assume another dx part at the same distance from the axis. For two symmetrical parts, the dE sin phi component gets cancelled as they are opposite in direction while the dE cos phi part coincides. Thus, only dE cos phi remains. Electric field intensity due to dx at point P will be 1 by 4 pi epsilon 0 dq by r square. dq is the charge possessed by the dx part. For unit length the charge is lambda. So for dx length charge is lambda dx. Thus dq is equal to lambda dx. We already saw this earlier. dE sin phi were in opposite directions and thus cancelled each other. So integration dE sin phi is 0 as for every dx part there is another dx part that cancels out the sine component. E is equal to integration of both the sine and cosine components of the dE vector. Since the sine part is 0, only the cos part remains. Putting the value of dE. Taking out the constant parts. We know arc equals radius into angle. So dx is equal to or d phi as the dx part subtended d phi angle at center. R is constant and we take it out. Cancelled 1r and now we have to integrate cos phi d phi. Putting the limits, from minus pi by 2 to pi by 2. Integration of cosine phi is sine phi. Evaluating the limits. We get 2 sine pi by 2 after integrating the cosine phi d phi and putting the limit values. This is our final result which we must remember while solving problems. Want to know how to find this electric field intensity due to an arc of any angle? Check out my video on my channel. Link is in description box and also on the end screen.